The number one lesson I can give you is, and I think you might agree with me, if you had to give someone one tip only for working on these, what would the tip be? 2 words. If you could give them 2 words, what would you tell them?
Go slowly.
I like that. Go slowly. Be careful. Same idea, but be careful. By far, the most common types of errors on these don't occur because you don't understand the math. It's because you transcribe something wrong, miss a symbol. Yesterday, we're working on 3 in my other algebra class, and we did it perfectly. All the algebra was awesome, but we got to the end, and Z was like 1/48th. We're like, that's not right. It should be like 3 or 1, right? Z should be 1 on this one. Do you know what the error was? The algebra was fine. It was just literally when I was copying one of the lines. You see the 5y at the top one, the negative 5y? I just didn't write it once. What happened to everything below it? It's all wrong. So someone asked a good question. What happens on a test? Let's say you worked on one of these, you did a lot of good work, but you got to the end and you realized that there was a transcription error somewhere. Go to the next question, do whatever you can. I'll give you a lot of the credit on something like that because you've proven you know what to do. If you show me like you're substituting, you're reducing, you're solving, but then you realize there's a transcription error, which means you just have to do the same thing over again. It's the same idea on the AP test. On the AP calculus exam, there's multiple part questions. The free response, they have like parts A, B, C, and D. D relies on C, C relies on B, B relies on A. That's a really common thing. If you make a mistake in A but do the proper work on B, C, and D, but with like an improper number, they still give you full credit for B, C, and D. So I'll do my best. It'd be nice if everybody didn't make those mistakes, but you are human, and you will. The first word, what's that first word you need to remember when you're working on these? Isolate. So you have to pick a variable in one of the equations to isolate. Which variable in which equation are you going to choose? Mar.
I picked the equation 2 for x.
X in the second one? You absolutely can. The most common choices are either x in the second or x in the third. You can make a case for either one. There's no surefire way to pick the easiest one, but I like x in the second one. That's great. So Mar, if you isolate x in the second one, you end up with x is equal to 9 minus 4y plus 2z.
I got minus 2z.
Plus 2z, because you're putting it on the other side.
Oh, true.
So, you notice, what did I do to my z? I put a little mark through it. Why do I do that in particular? And why do I recommend you do it? Yes, Harrison? Exactly. My 2's and z's are functionally identical unless I do that. Now, what's the next word? What's the next word that you need to remember?
Substitute.
Substitute. So if we substitute, where are we subbing this one in, Nick? Where do we substitute it in?
In the x minus 2y.
So the third equation and the first one.
Yeah.
So let's sub it into the first. You have to do both. Correct, because you're trying to turn this in from a 3x3 into a 2x2. So let's make the substitution. 2 times, instead of x, what are we writing? 9 minus 4y plus 2z minus 5y. You see I wrote that minus 5y? I missed that 5y yesterday, and everything went downhill, which we didn't notice until the end. Let's simplify this one first before we do the third. If we simplify this, what's that one word you need to remember at this point? Distribute. 18 minus 8y plus 4z minus 5y plus 3z equals negative 1. Distribute. Now what do? I distributed one word or 2 words. Combine like terms. So on the left, how many z's do I have on the left? I have 2 z's? I have 7 z's, I think.
Oh, I thought you meant 2. Oh, okay.
I have a z, 4 of them and 3 of them. How many y's do I have? Negative how many? 13y. And then if I subtract 18 from both sides, what do I end up with on the right? Negative 19. The only thing I would do, there's one thing, 7z minus 13y equals negative 19. There's one thing about that I would change. You could change the negative sign, so you could make it multiply everything by negative. You could do this, plus 13y equals 19. I multiplied everything by negative 1, but there's something that's a little bit out of order. I would like to change the order on something. I just want to get you into the practice of doing this. This is correct, but there's one. I would switch what, Liv?
Like the sides?
Not the sides. I would switch the, Alex? The y and the z. Why would I do that?
So y for z?
Yeah, I like putting things in alphabetical order. So there you go. That's pretty simplified, but that's...
There's only just one sign.
It's nice. There's only one negative sign, too. It's kind of nice. That's about as clean as it possibly can get. That's one of the equations, but it has 2 variables. We need how many equations if we have 2 variables? 2. So we plug this into the first equation. Now we need to plug that into the second equation. So let's do it in the second one. What was that second equation? Instead of x, what do we write? 9 minus 4y plus 2z. That's the x. Minus what? We're dealing with this one right now. Minus 2y minus 4z equals what? Negative 5. What should we do to this? We need to simplify it. Do we need to distribute anything? No. But how many y's do I have? How many y's do I have? Negative 6 of them. How many z's do I have? Negative 2z. And then if I subtract 9 from both sides, what do I end up with? Negative 14. Again, what could I multiply everything by to clean it up a little bit? If I multiply by negative 1, you end up with 6y plus 2z is equal to... Could I divide everything by something? What could I divide by? I could divide by 2. And what do I end up with? Plus equals... So now we have a second equation. Let's take a look. How many equations do we now have? So we have a 2 by 2 system. What method do you want to use on this 2 by 2? We could graph it theoretically. If I asked you to graph this, Nick, why would this be why would graphing really not be the best choice on this system, Nick? Take a look at this equation and this equation. If you had to graph this, you're graphing it and finding an intersection. Why would this system be not the best one to graph, Nick? What do you think? Well, what form are those equations in?
Standard form.
Correct. And when you have standard form, what do I like you to find?
Slope or something.
No, please, no. No. If you're in standard form, if you're graphing something in standard form, what did I like it? Find the what? Mar, find the what? If you have something in standard form, what do I like you to find? The intercepts. The intercepts. Remember how I told you this over and over again? You don't need to go to slope-intercept form. You don't need to go to slope-intercept form. But what happens if you try to find the intercepts on these two equations? Are they nice intercepts? Are they nice intercepts?
No.
They are not. So is it going to be easy to graph these lines? Not accurately. Is it going to be easy to graph these accurately? Yes, Nick, your question? Here's your system right there. You have two options, substitution or elimination. Who wants to do substitution? Raise your hand. Who wants to do substitution? 1, 2. Who wants to do elimination?
Oh, no, I want to do
Okay, I'll change this. This is not America where you have a choice whether or not to vote or not. Take a stand. Have an opinion. Who wants to use substitution? Who wants to use elimination? Okay, everybody, stand up. It's pretty easy to isolate z. Exactly. You could isolate z. So let's try it using both methods and see what happens. If we isolate z in this one right here, the second equation, you have z is equal to 7 minus 3y. Where do you plug that in once you get z equals 7 minus 3y? The top one, and you end up with 13y minus 7 times 7 minus 3y is equal to what? 19. And then you get 13y minus 49 plus what? 21y is equal to? What's 13 plus 21? What's 13 plus 21? 34y is equal to? Equals, what's 19 plus 49? 68. So what does y equal? Is that a good sign?
Yes.
Now, that was substitution. Could we do elimination instead? Is that a valid way of doing this? Let's do it with elimination and see what happens. Put your calculators away, everybody. No calculators. No calculators, no calculators, no calculators. So here are the two. I don't know why it spaced it out like that, but it did. So on this one right here, we need to line them up. How do you want to line up opposite coefficients, Mar? How do you want to line up opposite coefficients? Do you want to try to eliminate the z's or the y's? I like that one because you can multiply the bottom one by what? Let's multiply it by 7. Exactly, Nick. If you do that, what's 7 to... Oh, 21y plus 7z is equal to... And then you add these two together. What are these added together? Oh, 34y. What are these added together? 0 equals... Oh, is that pretty much the same amount of work? When would you want to use elimination over substitution?
when it's like set up for you.
If it's set up for you, definitely. That's a great answer. If it's set up for you. Like if you have 7 and negative 7 already, just add them together and you're done, right? I would also recommend to use elimination if you're being forced to do nasty, nasty fractions immediately. Because if in substitution you're being forced to use nasty fractions, elimination means you're just going to use bigger numbers. Would you rather use big numbers or nasty fractions? I would personally like to use big numbers as opposed to nasty fractions. So we're not done yet because we just have y. We know what y equals. What else do we need to find? What the other two equal. What value should we find next if we know y? Let's find z. Well, we know that z is, oh, look at this. We know z is equal to 7 minus 3y. So what does z equal? 7 minus 3 times 2 is 1. 6, 1. Yep, 1. Hey, now we have z and, oh, wait, what we need to find a? No, we need to find what? X. Look what we have up here. What did we find first? We have x equals. We know that we isolated it there. Are there lots of places we could plug these two values in? Sure. But what do we know? We know that y is equal to 2, and we know that z is equal to, y is equal to 2, and yeah, exactly. Very well said there. No, don't apologize. Z is equal to 1 right there. So what can we do? Oh, we can just plug it in immediately. So x is equal to, and I'll use highlighters apparently, 9 minus 4 times, what was y? 2 plus 2 times 1. So you end up with 9 minus 8 plus 2 is 3. So what would the answer, how would you state the answer to this? 3, 2, 1. Absolutely. If you had a lot of time, if you had more time, what could you do once you have your answer? You could check your answer. And I'll try to not use the highlighter because even though it looks kind of cool and fun and goofy, you can't see it in this room. I understand. I understand. Please put everything away. Called the length and the width. So to answer this question, you would need a length and a width. What do you want to label the length variable? L. What do you want to label the width variable? That is not a new mechanism, what we just did there. We are labeling our variables. They tell you this introductory piece of information. Do you actually need that information? No, that just helps you understand if your answer is remotely correct. But that is extra information you do not need in order to do this question. One particular soccer field has a perimeter of 320 yards. What is the formula for the perimeter of a rectangle? Alex Fay.
2w plus 2l
equals P. What do we know the perimeter is? 320. So we have one equation. 2w plus 2l is equal to 320. We have two variables, so how many equations do we need? How many? 2. We know that 2w plus 2l is... Oh, we used the first part. What else does it tell you? Its length measures 40 yards more than its width. So its length is equal to what? 40 plus w. How many equations do you see right there? 2. How many variables? 2. So theoretically, can you solve for both variables? What method would be the easiest method to use here? What have they kind of set you up for? Substitution, because they've already isolated L for you. You plug that into the first one and you end up with 2w plus 2 times 40 plus w equals 320. So 2w plus 80 plus 2w is equal to 320. How comfortable are you with finishing that? How many w's do you see? 4w equals 240, so w is equal to 60. We're not done yet because we also need length, but they tell you that L is equal to 40 plus w, so L is equal to 100. So there's your answer right there. You need to start somewhere, and the best place to start is to ask yourself, what kind of information do I need to answer